Hi, I'm Kathy. In this lesson we're going to summarize the conic sections. Our specific objectives are characteristics, identifying conic sections, and eccentricity. Let's start with some of the characteristics of conic sections. All conic sections can be written in the form ax squared plus dx plus cy squared plus ey plus f equals 0, where either a or c must be non-zero. Well, we can narrow this down to specific ones as indicated in the following table. The parabola, the conic section parabola, as its characteristic, either a is 0 or c is 0 in that standard form you saw, or general form you saw a minute ago, but not both. Examples might be things like y equal x squared or x equal 3y squared plus 2y. The important thing about a parabola, though, is when identifying it from an equation, only one of the variables is squared. For a circle, a and c are equal and are both not 0. For example, x squared plus y squared equals 16. In other words, the coefficients of the squared terms are the same, and both squared terms have the same sign. In this particular case, they're both positive. For an ellipse, a and c are different, and the product AC is positive, which means either both a and c are negative or both a and c are positive. And here's an example of the standard form of the equation of an ellipse. For a hyperbola, the product AC is less than 0. A and c could be the same for a hyperbola, but the characteristic that makes an equation a hyperbola is that a and c differ in sign. For example, x squared minus y squared equals 1, in which case a is 1, c is negative 1, so their product is negative. Well, let's continue with this discussion and connect equations to graphs. Summarize. Circles have equations of the form x minus h squared plus y minus k squared equals r squared. And here's a graph of a circle with center hk and radius r. Now parabolas. First of all, parabolas whose graphs are graphs of the equation y equal a times x minus h squared plus k. This is a graph of a parabola that can be represented by an equation of this form. It's a parabola that opens up if a is positive, a is this number right here, opens down if a is negative, and has its vertex at hk. Here's another parabola. This parabola has an equation of the form x equal a times y minus k squared plus h. Notice that the parabola opens to the right, or it could open to the left. It opens to the right if a is positive, left is negative, and its vertex is the point hk. Notice that consistency carried throughout the conics. Let's move on to ellipses. An ellipse that has an equation of the form x squared over a squared plus y squared over b squared equals 1 has an equation that looks like this. Notice that the center of the ellipse is 0, 0. This is a squared, but a is half the major axis, b is half the minor axis. The x-intercepts are a negative a, the y-intercepts are b negative b. Now what about hyperbolas? The equation of a hyperbola might be x squared over a squared minus y squared over b squared equals 1, and in this case the hyperbola has its vertices on the x-axis. The center of the hyperbola is 0, 0. The asymptotes are found from AB, a negative b, negative a negative b, and negative ab. Remember that b is an amount carried out in a direction perpendicular to the axis on which the hyperbola sits. Well, let's look at a hyperbola oriented in the other direction. Hyperbolas represented by the equation y squared over a squared minus x squared over b squared equals 1 have this orientation. Notice that the vertices of the hyperbola are on the y-axis, so have coordinates 0a, 0 negative a. Asymptotes are found from the ordered pairs b, a, b negative a, negative b negative a, and negative ba. Well, that's a lot of information. Let's use some of it in some examples. Let's decide on the type of conic section represented by each equation. And the first one that we have is the equation x squared equals 25 plus 5y squared. If I subtract 5y squared from both sides of this equation and then divide every part of the equation by 25, I see that this is the equation of a hyperbola. Well, let's try the next one. I see x squared and y squared, and their coefficients are the same. So I think that what I have is a circle, possibly, but let's put it in standard form to see. I'll complete the square on x by adding half of 8, which is 4, squared, which is 16, to both sides of the equation. And I'll complete the square on y. Half of 10 is 5, squared is 25, so I'll add 25 to both sides of the equation. Now factoring, I get x minus 4 squared plus y plus 5 squared equals this. Now this sum is 0. And so there's two ways to describe the resulting equation. You can consider it just a point for negative 5, whoops, or I can call it a circle of radius 0 with center for negative 5. And both descriptions result in the same graph. Well, why don't you try one like this? Here's what I want you to do. I want you to identify the type of graph from the equation, and we have the equation 3x squared plus 6x plus 3y minus 12y equals 12. Pause the video and try this one. Well, let's see how you did. I see that each term has a common factor of 3, so I'm going to start by dividing everything by 3. And then I'm going to complete the square on x and y. To complete the square on x, I add 1, so I need to add 1 to the right-hand side. To complete the square on y, I add 4, so we need to add 4 to the right-hand side. And factoring the trinomial in x, I get x plus 1 squared. In y, y minus 2 squared, and that sum is 9. And I can see that what I have is a circle with center negative 1, 2, and radius 3. Well, let's look at the general definition of a conic, and so we can talk about its